For today's class, I'll talk about what's the process. So like, let's know the process, and then we will have one more. It's like I will spend, maybe we need to have much more time. For the rest time, we will have actually prepare 4 questions about multitasking and threading. So actually will be part of the question and for the assignment of possible quiz or final. How to design. So when we talk about multitasking or the multi-thread, okay, how do we handle it? We are not really require you to implement the like really the source code, or like we are using the pseudocode, just like you need to tell the logic how to handle it. And when we need to decide, we need to think about how to handle the code like in the same time. So because it's called a multi-thread. Multi-thread is that we will share the resources together in the same time. So let's say if we have only limited to 1, then how can we check it? So maybe we'll spend much more time to discuss. Then we can start right now. Go to some boring stuff like definition, process. So we call it what's the process, and then what's the threads, and then the PCB, TCB, and process concept. So it's the fundamental to the structure of modern computer system. And then it's like we try to analyze problems, sometimes synchronization, deadlock, or scheduling. So we need to know scheduling. So when we talk about the paging and also the VM, the virtual memory, not the virtual machine, but this one is a virtual memory. Like we need to have a scheduler to arrange different threads, like assigned to the CPU. So we need to know. Okay, so right here. So for the process, sometimes in the OS we say process, or you can just think it as a program itself. So if we execute a program, sometimes you will think about like you try to execute a program, what you implement, or the program is already like you are executing. Well, let's say we have the Zoom, PDF, Word, or maybe right here, maybe some text editor. So they're all possible. Okay, they can be an application. Maybe it's really hard to let you imagine what we talk about the like what's the uni or the single position, like because it's really long time ago, like we did 20 years ago, 30 years ago. So it's really hard. So if it was the single process, is when you click a button, let's say open, then you cannot do other stuff. No other action can be accepted. If you want to print a document, so right here, the PDF, if you click the command like Command P, so actually, if you, let's say on the Word, you're typing something, and then when you want to print something, you cannot finish the typing. Either you have to stop it, and then wait the printing job complete, then you can go back to typing. So can you calculate is the difference? But for multi-thread, so it's like you can click the button Command P to print it, and then you can keep on working on it. Or like when you click the button save, it's saving. Or like you can export the PDF, but you can still like working on something else. So here's the reason why like the generation, the evolution change. We have the multi-threading comes out. And for the process, we always include the program code. So we call the block. Also, it's a set of data associated with those code. So we say, okay. And sometimes we so-called the dynamic memory structure. So it support the extraction of the thread, control the process. Sometimes we have the function to call it. We have the stack. So it's called dynamic heap. So we need to call the function. So from the heap. And also we will save the content information maintained by the kernel. So the kernel, we comes out the term like covered by the end of last lecture. So kernel, I didn't really like elaborate enough. So you know it's like if you remember the diagram, so in between the application and the hardware. So it helps us to handle the shared resources. So you don't have to really know how exactly, let's say the Word, the application want to send a print job. then the kernel will help us to handle it. So we will throw it to the printer driver. So sending the data copy, like what's the job printing it. So we don't have to really kind of similar concept of the API server. So we're just sending requests and then with the data. And after you send those requests through the API, the kernel itself help us to deal with the hardware. Okay, how to print the job. So we don't have to really care about it. So that's how it works, a kernel, and then also support the context switching. So it's called multi-programming. So, and then the process elements. So when the program is executing, this process can be like uniquely categorized by the number of elements, including like identifier. So we have the PID. Sometimes we give a PID, okay, this program ID, and then we have the state. So it's like idle, executing, active, like this, and priority. So also we have the priority sometime in for the scheduler. Scheduler will be later in the later lecture. So just let you know, we have the program, so the PC memory pointer, the VM, the virtual memory register, and the content data, IO status information, accounting information. So they are all included in the process. So right here, you see, okay, they're all saved in the process block. Okay. So we are skipping. And we already know the process, and then we need to know like what are the process states. So when we execute in the memory, we have different process, like let's say A, B, C right here. So we they will occupy the memory address like this. So if you want to change, okay, right here, 5,000, just example, okay, it would be process A. Maybe we say program A. So we take it from here, 5,000 to 511. So we have three different processes. Okay, sometimes if we want to change, right here is just example, if we are starting like as a 100, when it's the timeout, we will go to another like dispatch program and then come back and do something else, and then IO request and come back. So here's like, we have some interrupt process comes in and then change it. Okay. So when we have, this one is called the two-state process model. So it's one of the example, like if we have entered the process will be like it's not running, then with this pressure is running and exit, or no, we pause it and then we go back. Okay, it's not stop, and then keep going to do it again. So it's how we do it. And so when we do this, that means we have multiple process. That means we need a queue to like let all those like process get in. Actually, when we break the process, actually when we do the multi-threading, and it's more than that, because we have mechanism like round robin is like taking terms like for the different process let it complete, but we have the different time slot. If we not able to finish process A, then we need to go to like when the time about, let's say we have 1 second for process A, it would be fair. So next one will be P and then C and go back to A, B, C. If A already finished, then I will keep going on B and then C. Okay, so we'll be like this until everything completed. And when we try to create a process, then it's like we'll add to those like, okay, the OS will build a data structure that we use to manage the process and allocate address space in the main memory. So the main memory, that means the RAM to the process. Most common, the process will be spun by existing the process, and we can create by the OS by pulling a service usually. We always say the time sharing. So it's like when it gets in, so we share the time like equal. Most of the time we will make it like equal. And then sometimes we will terminate the process. So we should able have a method to terminate. So it's a hot instruction. So it's an explicit OS service to call to terminate. And we need to like as an active application, the action of the users will indicate when the process is complete. So it's like we need to know, okay, it's time to exit. So I'm not going deep to, because you know the two model is simple, but this one is called the 5 stage. It's more like common. So when we have a new one and they're ready, but I will go into details. And right now I would like to jump to the some discussion about the case. So we'll be right here. Okay. Forgot my water. Okay. Okay. So let's look at the question first. So if we have a system and we have a single resources type and just one resource, and then we have two processes, P1 and P2. So each process can request a maximum 1 unit of the resource, and then the resource is the initial available. So write a pseudocode function to determine if a process can be granted a resource and based on whether it currently available. I didn't show you a source code or the pseudocode, so I can show you the right here. So for the pseudocode, just like, okay, can I grant it? So it's give me the status and then check it and then return. So I quickly roughly show you. So you can, I give you maybe 5 minutes so you can think about it. So what you need to think is like when you manage the OS as an OS, you need to think about the source code. Is that okay? Two processes. I only have one resource. So you can just think it's a flat. So it's like or Boolean, true or false. So right now we have one resource. It's like in the beginning, it's available. So I can make it available, it's true. Okay. So two process will get into it. So maybe I have a loop like checking is this resources is available. That means it's true. It's true, then you can do something. If no, then you need to wait. Okay, until you get it. So I will let you think about it if you want to. Do you know how to write a pseudocode? Okay, so if you can type it down or somehow, let me grab my water so I will come back. So you can, I would like to invite some volunteer to share like, or we can discuss though. I try to make it more like interactive. So I'm also, I wish help can help you for this exercise because it's going to come out for the some assignment and also for exam is possible to like how to write how to manage this. Okay. So you can think about it like based on this question. So the format is casting. I can read it. All the pictures ready. So I would like to invite I think it's not here, right? So I can hear. It's okay. So if anybody is ready or like if you I'll give some time. So I will invite a volunteer help and show me how to write the Mhm.
Will we have a variable inside the class or, yeah, inside the class, to that, private that says whether the resource is already taken? Like a private variable we have there, or do we have to actually like go and check and see if that,
Um, as a pseudocode, you don't have to really, but you can say, okay, if it's a global, you can say it's a global. So you can put it outside of the function. So you can mark it as a global variable. So it's like called resource equals to true. Let's say it's a Boolean or something. Then you can make it's a private. You can use any, because it's a pseudocode. So you don't have to think about like what's the data type. Like let's say if Java, we need to say it's a private, public, or maybe C or like Node.js. We can say it's a global variable. So we can just put it outside the function. Okay. So just let you quickly come here. So we have the function, and then we do have the some like global variable outside of it. So you can let you see. Here is the global variable outside of it. So which one request, and then 1, 2, 3. Okay, come back. Okay. When you design the function, you cannot only think about only one process, but you need to think of, okay, this part of function can be used for both. If you get the power in China to do and if you're ready, or if you're willing to share, then I welcome. You can show me how do you design, and like where your student code. So you ready?
No, I'm gonna ask you.
Okay.
and
Okay.
you can come with it.
So you have the, okay, so we will assume Boolean is available. So if the local variable is available,
Well, it's checking to see if, since you said there was a flag, a local variable saying it's a flag, if there's not, then I have to do a whole lot of other stuff that I did.
okay, so it's really, okay, I really well. So for the process, we say it's the program. So when we say for a program, we need to have a function to check, okay, are you allowed to access it? So what you're going to do is like this function will be shared, or like will be used to different programs. Okay, so they're using this one to check the resource. Okay, and then we have one global variable. Maybe for your implementation, you will only think about, okay, I only think about my own application. But for the OS system, it can be also is a big program, right? So it will manage all the resources. So some small process, other process will be call this function to check, okay, am I available to use this one? Okay, so how do you think? I will give you example. May I have your pen? So I give you the example. Let's see. Because I want to get one example so I can like we can discuss together. Okay, let's say I told you make okay. If I have a Boolean, okay, I have a Boolean, so it's called the resources, right? So I will say I say always available. So I will say it's a true. Okay, like this.
Yeah.
True. So I have a function.
And since we now have full red, I'll put that in.
Yeah, maybe I should like check available. Okay. So maybe I will see, okay, maybe I'm the get the request, or like if I can get the global SSH. So because I just need the pseudocode, so I don't really have to implement. So I get it. Okay, maybe I have a program. I get a program.
Yeah, that's
So
why I put, request, because because it still gets the request, but.
yeah, sure. Like any that depends how you design. So we always check the if, right? If I get a global if result this is true, like you can true is true. So the connection true is true. Okay. So if true, what we are going to do? Else. So what will we do? It's right here, right here. Okay. So if we are waiting, we need to add a while loop. So also you are saying, okay, why not I only check it once? Then how about I need to keep checking until I get it. Then how can we get a while loop or something? So just like think about this. Okay.
Okay.
Okay. So right now it's pretty simple, only put two process and one resource. And just need to check is it available or not. Are you ready? Ready? So I would like to ask some volunteer, how would you like decide?
Mine's really basic.
Okay, yeah, sure. I will look at it. Okay.
So I just have setting.
Okay, we're checking. Yeah, okay. Right here, okay, so. Okay, good. So you will set it to false and then available. Wait, okay. That will be one more. Okay. Here's the logic. And if well, this one is the warm up. If we look at it, okay. Here is the example. So let's say we have the one request process. Okay, here's the global value. So it's like called available. So say it to true. Okay. So we say we default is available in the beginning. Okay. So P1 or P2, wherever. So when I have a process to request, so it will be available. If I have two, I could do in the same time. So it comes in. So I will check the condition. If it's available, what am I going to do is correct. I change to false. So I access it first. I change the flag to false. That means other process are not allowed to do it. And then I will return, okay, or they granted or wherever. So this one is the return message. You already successful to do it. If no, I say not available. Okay. So based on this one, if I give an example, so no matter process 1 or P1 or P2, call this function. So P1 will put the process to request P1, or process 2 will change it to P2 and change it. If process 1 goes in first, and then it will change the flag to true, and then it can execute its program. And when P2 request and then check the condition, because it's false, it will return, okay, it's not available. So it will wait. Okay, so based on this one, I ask, I want to check, keep on checking when I'm ready to access the game. How can I modify this pseudocode?
So you'll put in the else statement, you'll put a while res is not res, so that way it's true. It'll then just print to the screen, please wait, resource is unavailable. And then when it finally falls out of the loop, you'll recall to the main function.
Okay, so if like based on this one, could you you want to write something like right here, like show us where do you put the while loop, and they say based on what you say. Okay, so at the you can based on this one just modify.
So so what I was gonna say, so instead of doing the return, you'll do what I was saying is you can have a while loop that says.
Or you can what? Okay. Okay, you can both, yeah, you can get it half, yeah, okay, or you can talk, you can write it down, yeah, we can talk, okay, yeah.
Well, the bottom example usage, so like, if you set the availability true, you process the result. If it was false, then you could set a while loop saying, until it becomes true, keep rolling.
Okay.
But that would simulate like that after the clock.
Yeah.
Yeah, so
But wouldn't you do that? In the bottom.
Yeah.
not the
Bottom, or okay, I would say, because you can say can grant a resource, right? So for this function, when I call it, I would keep waiting, or like, we can put it right here and do the loop, but check, where did we check the resource? Which part did we check it?
We're checking it from the top.
Right here, the function. So because the function belongs to here. Okay, so that means the while loop should put inside.
Yeah.
But okay, then where should we put? Where he's writing on it, and just like modify a little bit, change it, so we can wait. That means we are not really return it, but because we are waiting for it, right, we will execute. But it's like, I need to know when can I do it. So we will put the while loop, I put the loop, and see when I can get the resource, then I will execute some part. So instead of just like return it, I would keep on waiting. So how can we modify? So the hints will be right here. Which one?
After that, like, in the while would be after the else statement. or the else part, and then wouldn't you just be able to do while resource available is false, just keep running the can grant resource function?
Yeah.
What's the original function called?
Can grant resource.
Okay,
Can
yeah.
grant.
Or yeah, sure. Okay.
Well, just in the else block, instead of the return statement, just have the.
So what I did was, you'll have you'll have a while.
Okay. So based on what you
I said else while
Say like, wow.
not it purchase the grade, wait, please wait, resources not available, and then it does a recall to itself, and then it says.
So
Because once it becomes available, it'll immediately call this. Get
But if it's not-
I guess it should.
Get its,
okay. So based on
Maybe
this
inefficient.
one, how to think? So you try to modify the else. And then if else, that means like if you cannot get it, it goes down to the while loop. So it using the same not, so that means it's true and keep. So you'll keep like waiting for it.
Isn't that infinite?
No,
It will
once
be-
it becomes available.
And not. So once it's available, then it will change to true. Like once it's changed to choose, it becomes false, right? As a not, so it will jump to, then it can return it. Okay. So it looks okay. And or
Because I did know how else to do I know how to, what we would do, would we just code into it the true part of the statement, if we were, or do we just kind of recall, and then since it's true at this point, it'll automatically go. It'll automatically go. Without, I guess I kind of did it efficiently.
or how about this? So I just keep looping and wait, right? So until I get the it's available. So then do I need to put the if conditional, and then I just take it out? So I just like, once I'm able to get it, I change to false. So do you think, is it possible to change to false in the same time or meanwhile?
What do you mean by this?
So is it, right now we have two processes, right? P1 and P2.
Right.
So we have the programs called a while loop, and then we're checking the status when they comes in. So do you think it's possible, like we, okay, yeah.
Mine's just a good question, but, if, you said we only have one resource, right?
Mhm.
How is that one resource running this program and being consumed?
Okay, so the resource is like kind of like general idea. Okay, so we are not talking about, because the CPU always can execute one instruction. Okay, so actually you imagine that for this function, we calling, okay, the two process A and process 1 and process 2, we call this function and check. Am I have a right to get this one. Maybe the resources is the print job. Actually, we have the sequence just to make it really simple. We say, can I use the printer to print it? Okay, just make it really simple. Actually, in reality, it's not really doing it this way. Okay. And I'm asking, is it possible have two processes can I get both of them there true? And then they will change it to false. Is it possible? Is it going to happen in this situation?
If both processes wallet, it would be, it would be, they'd go on a stack in a random order, pretty much, or.
It's not just to say because if you remember, like because I just like keep reading the lecture because like we load it in the stack and loading, so all the instruction will be done once by one. So when we load it, so it won't have a instruction like do it simultaneously, like same time as it. So there should be one go first and one go second. So maybe process one already access it and change to false, then when P2 access it, it should be false. So it's not going to happen at the same time. So here's like really kind of like warm up exercise, one resources, two processes. So I said,
I do have a question. So let's say the process gains access to that resource. Wouldn't the resource then overtake the? Wouldn't it overtake the other requests? I'm sorry, I'm trying to understand how one resource can do all this plus process.
Anybody can help me?
It's just like a theoretical, like, it's just a simple thing, I'm just saying, one resource, two programs are trying to use that resource, so how do we kind of go around that?
Oh, and we're just.
This isn't like actual CPU stuff, it's just.
Sorry, I'm thinking.
Yeah, okay, so it's just a warm up. Okay, so right now you know how to do that. Okay, you don't have easy, right? So everybody can get it. Okay, so we will move on to the second question. Challenging level up. Okay, so I think podcast will be stopped by right here. So right now we have three resources, ABC, and we have two processes, P1 and P2. So where which process requests the resource and the system need to ensure no deadlock. So where is the deadlock is like we don't have enough resource or like keep waiting for it. So deadlock is like kind of looping, so we cannot execute. So while pseudocode function to check if the request resource is available. I just give you some define or like give you, so if let's say we have the let me use the word. So right here. Okay, so we have the ABC, right? So let's say A, then we have the B and C. So they are the resource. So we can declare like this. Because I didn't really tell you, so maybe I can put like 1, 2, 3. Or like, oh, okay, I'll make it more simple. I will change the advanced level later. Okay, so we have ABC 1, 2, 3. 1, 1, 1. So they are only have one, and P1 and P2. So when they request, send a request, they will need to have their when they call is more like general for the function. So what parameter first, like which program and the resource, how much do you need? It will send to the function. And because we already understood that like that loop and wait, so I asking you need to put a while to check if they're available. If yes, we'll do something. If yes, then you execute. And after execute, you should take some action to finish your job. Then actually you should do something. Okay, so change, or once you gain your resource, not turn, you need to free the resource out. Okay, update. Okay, so you need to like commit this part, and then you can just like, I say, you can just like exit or so far anyway, just like stop. Perfect. Or like you just put a return right here. Just there's no, okay, the function is done. Okay. And so basically we have two parameters, 1 and 2. First one is like, okay, when P1 call it, say P1. So if let's say I need to get the A1, I need A for 1. I do not need B, but I still need C. Okay. And here's the case if for P2, I need only A1, A and B. That's it. So kind of like just like advanced level based on this question. 2 process, 3 resources. Then how can we write the program? Just I need a pseudocode, like similar to this one.
What you want to run?
Yeah. But when multi-threading, actually, they are actually just depends on which one. Send it, yeah, go first, and then they will execute, and then we'll keep checking the resource. Then how can we implement this part?
When you want to check that resource A is available. Since the P1, P2, like the only resource they have is on this A. So you wouldn't need to worry about B, C.
So
But you have to.
In this case, that would be like fine. You would only do that with removing, if we didn't.
Oh, I thought, wait,
okay, good.
So I mean,
I think the
like,
question is still.
Probably yes, but probably not.
Okay, that help.
Do you check if all of them are there first? If they are, then you can use them.
Or we need to check each one second.
Or you can add another orders. Okay, maybe based on the request, because right now here. Okay. Okay, here's the request. Let's say the request format will be because I tell you the parameter, right? So which program and the request. Okay, so I would tell you like A, B, C, which one do I need? Okay, so because you just need to use the pseudocode. So you do not need to think about which language you're using. So just like give some condition or like checking if, or like how to use the while loop, or like should you put the if before the while, or like the while should put before the if, or like this anyway.
So if you want to run during the process, while the process is going, you can, well, it's like like future of the process, you have like a while loop inside the resource activity check to see if the process is done. Like call to our original, like, if we pull it, I mean, like check and see if it's finished or done running. And then I can keep adding, like, well, once the time is available, you can clear it up. That way you never have that on. And
To avoid deadlock means like if you don't have enough resource, but I allocate it to that process. Okay. So let's say so that's why we need to have a condition to check. If right now the P1 already have the resource, I'm using A1 and C1, and B is available. But if you didn't put the condition well, you say, okay, B is available because P2 requires A1 and B1. So each of them, both of them together. But when you only check B only, and you assign to it, but A is 0. So we have the dialog because you cannot use A1 in this moment because P1 is using it right now in this. Okay.
could we have a while loop that we have like a while loop that says, that, or not, a for loop that check each individual, resource to see if it's available, as it is. a
Um,
while.
you don't have to worry about this one like for loop or somehow, you can do it just like you can, because if you know pseudocode, just say if and then check if A available or like N, like you know the condition.
Yeah.
Okay, so you can just do it like that. So you don't have to worry about like how to actually.
They were gonna get it.
Yeah.
So-
Bill, mhm.
But, the reason I was saying the loop, the for loop typically is because it'll check, you can have it check each individual resource to see if it's available.
Yeah.
If it is, then.
Yeah, you can use for loop, it doesn't matter, but like more like for abstract thinking, how can you check it? Like you say for loop, then you go through ABC one by one. Then how we going to do? Yeah. Or like how can you put the syntax like one by one? So you can make sure. So because when we load two portions here, here's the function, right? Okay. So we load it to the bottom. So when P1 we're saying and P2 we also have the same copy. So we are exactly calling this function. So we have two and P1 and P2 will call this function. So who get the resources? Who can do it first? Because right here, maybe let's say you never know. CPU and then the queue and stack. And also we have the heap. And what else? Maybe like we will put all these like for the instruction. So actually P1 and P2 will execute both function to in the same time when they have a chance. So either one of them will go first. So they will check the resource. So right now we have A, just assume they are all like available. So they are A, B right here. So here's the resource you have. So why not I asking, okay, P1, it requests A1 and B1. And P2 requests the resource B1 and C1. Okay, so P2 doesn't need using A, but for P1 it doesn't need C. If it comes, you need to think about the condition. If P1 comes first, it should be goes to. Why not the state? If P1 get it first, it should be A equals to 0, B equals to 0, and C equals to 1. But and then when we execute P2, we need to check, okay, can we get B1 and C1? If no, then we need to wait for it until it's ready to access. And how can you write the pseudocode for handling this question? Any idea?
While A,
Mhm.
B, and C are available.
Okay.
While they're all initially. Then you can use them.
While A, B, C, M. Okay, so you say while.
it'd be if,
Okay,
So
so
if
that's
A,
like.
B, and C are all there.
because if you started at the beginning.
Oh, actually, I can make it really simple. 2, 1, 2, wherever, just forever loop. Okay, that infinity loop, and then I would say if, right?
Yeah.
So A, B, C,
Available.
okay, available. Okay,
Right, access to resource.
Yes.
so you can access, okay, can access.
And then you need to change the status of A, B, and C, whichever one you use.
Okay, so we will update like maybe. Okay, so make it more detailed. So are we really checking all of them or just a match? Based on what the request? Okay, request. So if the request say, okay, so we can say for loop or somehow just like, if the request is request, we can use for loop, just match. Okay, so 3 items. So if E match -1 can be equals to 1, then we'll get SS, and then we'll update. We change it, or like just like say -1. Okay, so -1, and then we can execute our main program, like what I just execute. Our program. Okay. So once you finish, we need to free it, right?
Right.
Just like +1. Or like based on which one you get. Or like so, just like free, and then you will exit or return your program. So does it this logic?
So you're using it, updating it, and then putting it back. That's the point of the statement, right?
It's okay, like I'm putting it inside the for loop, or should I? Your window is while it's infinite loop, so okay. So this one, I just put it true. I think so. It's true. So when now the request is the okay. So when now it's right here. So I should take it out if it's available. Can access? I can just. How can we jump out from the?
You can put a break in there.
Yes, okay, so I will break it and then close it, so we can. After we get the access. Then we can, of course, like when we access it in the loop, then maybe we will. Do it right here, right? Right, take it out and break it. So we stop the loop and then we'll execute our main program. So once you finish, you will free the resource. That depends on which one will be. So once you free it, this one, okay, so this one will, so in the P2 at the same time, so check it. Let's say if P1 comes in first, it will check like get a for loop, check ABC is available, I'll match, okay, I need 1 for A, 1 for B. Okay, I don't care C. I do not need it, right? So it's just like skip it. Okay, skip it, and then it match, I can access it. Then I will remove it. So I will leave the break. I will break the while loop. Then I can execute my main program. But you know that sometimes the IP it will have different address. So maybe it will go to the queue or stack or heap, which we maybe not yet execute the main program. Okay. But in the meanwhile, when the while loop also we are executing this part, it will keep checking it. Because the P1 already get the process and minus. So when we check the for loop, okay. So right now the current, if P1 already get it, then should be the status like this. So when I want to get B, we don't have B. So we just like, so the condition is false. So we'll keep waiting in the loop. Okay, so loop and then just like keep, and then we can execute the program when we free. So we'll go back to the loop and check. Okay, so when we free the resource, it will go back to the state is one. Then P2 can execute. Yep.
When you want the break inside or outside of the statement? I'm assuming in, but. You would.
We need it in, because you have to prove what you recognize.
Yes, yeah.
Yeah, so
Yes, we should put the break in, because if we fulfill the condition, if you put it outside, what happens?
If you break breaks, and then you get that loss.
Yeah, you always break, then you get a deadlock. Okay, so. Here's the kind of like, based on this like advanced level, we think about, okay, so it's available. Here's the kind of like assumption, like depends on the source. This one I gave a 532, and you will say, okay. Right here, we need to check the this one is without the while loop, so it's just like the structure. So okay, it's available, so we can check. Okay, this one is just called a function. It doesn't really think about. So I say for the pseudocode, you do not really think about like should I use for loop or like what kind of loop like to check the results. But we need to check the have a maybe you can give a function. But I say, or just have a statement say, okay, check the availability ABC match it. Okay, so that's how it looks like. And I will give you one question. Actually, we have two more. So based on this one, so if we need to simulate the allocation of resources to a process and check if a system in a safe state, implement a pseudocode function for the allocation and safety check. So just give you a sample. So we need to have a while loop and check. So it's like for, okay, in case right here, so we talk about for loop, right? So we're using for loop and check. So we minus, and if not yet finished or like can allocate, then we will based on, because I put it as a match. So if goes up, I would take this as an example. If I change it, right now it's not just one, but the available resources is more than one. Like let's say 5, 3, 2. Then the logic will be much more harder because we just like think about like kind of like, yes, we have it or no. But if we have like multiple, okay, if the resource with right now in this moment is 5, 3, 2, and then let's say, let me copy this one. So why now one take 1, 2. Okay, let me take it more. Okay. Or let's say like this. So if the available resource ABC will be 5, 3, 2, process 1, 1, 2, 1, and process 2, 6, 2, 2, like this. Then how can we modify source code and able to like, we say safe mode, that means like if we don't have enough resource, we shouldn't like allocate the resource. We need to check. If maybe sometimes, yes, the program itself, the application, the process requests more than what you're able to provide. Then what are you going to do? When you implement the function, you need to think about like both of them, they will execute in the same time and check. So how about this one? How can we modify?
You would subtract the amount of resource from the base resource, and then the other thing we did, and we have an if statement to check there, plus functional resources. That way you can, if you get if the requested resource is too high, then we don't want to give them, we can give, we may be able to give that the maximum resource, or we just not give them any resource at all.
So you're saying because on this page, P2, since A is 6 and we only have 5, we have to decide what we're gonna do with that.
We have to decide whether we're gonna give it 5 and hope the program run fine, or fine and crashing, or we just go, nope, sorry.
Okay, so I give it normally when the process requests like more than what you can provide, we shouldn't give it execute. So we stop it. So like sometimes we have the error message, the log is say, okay, you cannot get it, like you're not allowed to access it. There's a reason. So as an OS, like the manager, so when you ask more than what I can provide to you, I say, no way, I won't let you to execute, right? So we need to check. So instead of like checking true or false, like lower level, yes, available, not available. But right now it's like we have multiple resources. Then how can we, also we say called a safe mode. Safe mode, that means that, okay, I make sure I have enough resource to assign to you. If no, I'm not going to let you do it. Okay. And if you ask like why, I think before long time ago, I asked like the blue screen. I say why it happened, because how the OS, like sometimes it make the mistake. Also, some programs say it assign, but it should. I know the next like t equal to n, the resource supposed should be available. It should be enough for next process to use, but it didn't release, even it complete. Then you say, okay, the resources are not available, but you allow that process to execute, so it crash. Okay, so how can we just change the maybe the while loop or the if statement, the condition? So
Could you have a second processes, just to check to see if happening.
okay, so if then how about if I'm allowed to it, then I need to change the resource, right? So if like P1, suppose like, okay, maybe P1 comes first, we will check, okay, it's all available. Then we will minus it and then go to P2. It will check the resources. Then we will just go throughout it. Is it enough? Or like we will choose the like pretest. What's pretest? Okay, I'll check. If I minus it, it's greater than what's enough? Like let's say greater than or like greater than equal to 0 or greater than -1. It's okay. Okay, either one is okay. So if we check, okay, if it's possible, like greater than it, then we will let it be true and then minus it. So that means like we need to check all the resources like if I minus it, is it equals or greater than 0? It's possible, then we can execute. So that's how it looks like. Okay. So also this one is like, okay, so from this all the process, this kind of just a Python example. So it's allocate. So right now, based on the resource we have, we minus it. Is it possible? Okay, we will check. If this one is just like kind of like reverse, it's okay, the work is like based on the available. So it will add it like some, okay. So if finish I, we will say to true, the progress make equals to true. If no, then we will break the for loop. So, and then when each one finish, okay, so it will loop it. Okay, so it's not finished, we return false, if else we return true. And finally, when we go to the another function, we'll check, okay, so we based on request. Is my request resource is like greater than available? Okay, so that's how we check. Okay, so if returns false, that means we cannot do it. And yes, true, then we can. So this is the, can we allocate is right here. So available is how much work we have, and then request. So is that based on the allocate? So the max will be the how much we are going to assign. So right here. Here's a function, so we call that the save state. Like we're going to check. And the last one, but I think this one's like complicated, so I just go through. So also because of the time, I don't have enough time to let you to check. So right here, okay. So we have the like multiple process, and we will implement a pseudocode function that will apply the blanket algorithm and check if a new resource request can be granted without causing a deadlock. Okay, same with the deadlock. Function should be handled updating the resource allocation, checking the safety, and rolling back if necessary. Okay, so here's it. So when we request it, we always like we'll check, okay, if I minus it, do we have available resources? Okay, so when I ask the question, when we check, we always need to check, okay, is it possible to let us to allocate? So we'll minus it. And we always call the function, okay, if we are able to check, when we check it, after we kind of like checking if I minus it, still available, yes, true, if no, it's not available, okay. If that resource is possible, then we will, okay, based on the ID or like we have the array, we say, okay, we'll take it. Okay, for the safe state is like based on how we check. So safe state is the similar to here, like the work and then available resources comes in and the finish. So in the beginning, like finish, they're all false. So they're not yet execute. And here's the called the rolling back allocation. Rolling back allocation will be okay. So based on the resources and then plus the request. So it's like why now? And we set the array to all the process. And if we already allocate like to that process, then we will minus it like how much, how many resources they request. Okay. So, and then we are doing is true. And then we talk about the progress mode. Okay, it's in the beginning it's false. So it's the same, you see, like based on what we do. And then we're checking all the process right here. So if we are going looking all the process and then if not yet finished and it's allowed to allocate. And if you remember our question 3, right here we say we have multiple. So it's the same logic. It's just like extension right here. Oh, wait. Okay, yeah, right here it's the same based on work. So if we are going to assign, so we say to choose, so it's working on it, and then the progress make is true. If no, just okay, done, break it. Okay, so finish. So basically here will be the same. And when we have multiple, let's say we have the resources right here, and then the allocated resources A1, C10, and then we will have the array of the objects 201 and maximum. Okay, so right now how many resources we can use? 3, 2, 1 is recurring, or like here 212. And if let's say the P1 request 101, so when we call like request the resources, we check the available resources right here, and then the allocate resource. Because this one is the assumption, like because the question is open-ended and for discuss, I can change all the number. So like based on the question, and because like more likely is more important is about your logic to check, okay, because for the maybe assignment question, it won't like go to this like difficult and hard. So it's more like simple. You don't have to really like checking, like make sure, okay, how many resources like using in this moment or something. But always try to maintain is like, okay, if I have, when we only think about 2 programs, like or like 2 processes, if I change to 3 or 4 or more than that, we are always like calling the same function. Can your function like handle all these requests? Okay. And is an example. I know for the question 4 is like kind of like mix of all previous and combined together. So actually, if you understood, then it's not a huge problem. And I'm not requesting you like in the assignment or like any quiz or something to like writing all this, and just like need to provide the pseudocode. More likely I just like let you to stay on the question 2 or like based on the one we discussed. Okay, so if we have 2 processes, and then how can you allowed to check? Okay, and you're welcome to using another function. Like actually it's a good practice. Like right here the example, we always like call another function, and those function is reusable. So the function calling another function, so we can check, okay, for the resources or like for specifically like to maybe assign or update, remove. So you can do it in this way, or like you can put it as a one. Not really, because this one is not really say programming. Like you don't have to look really make it really beautiful, but it's a good practice. Okay, and so far will be finished the discussion. I think you already, yeah, because I'm not going back to the lecture, so it will be for the next. If you like the practice like this, I'll try to prepare more So you can discuss and think about it. You like the exercise or share? Okay, okay, okay. Then I will prepare more something like this, so you can have more interaction and think about it. Okay, yeah. So this is more, yep. So will be that's it for today's class. Yep.